So I will briefly introduce Rafael, who's a friend of the house, a long-time friend of me and all the Ferryfield group team. He's an expert in quantitative risk analysis and decision-making for capital-intensive industries with a deep specialization in mining, energy, and major infrastructure projects. He's the founder of ImagineRisks and the long-standing partner of us, of the Ferryfield Group, and also Safran Software Solutions. He has helped organizations around the world to implement advanced cost and schedule risk analysis using Monte Carlo simulation. So I will leave it to you, Rafael. Thanks so much for taking the time to all of the attendees. And this meeting will be recorded, and you'll be sent the link during this week. So thank you all.
Thanks a lot, Gustavo, for the introduction. Hello, everyone. So my name is Rafael, and today we're going to see a masterclass, a quick intro on how to use Safran Risk to determine schedule and cost risk of mining projects. We'll focus at the same time both at the software, Safran, and also mining projects and what they usually entail, what kind of risks they usually have surrounding them, okay? So there's going to be very little PowerPoint. The focus is really doing the quantitative thing in the software itself, okay? We hope we can do it in 45 minutes or less. The event will be recorded, and there's a Q&A time at the end, so please feel free to write your questions at the Q&A or the chat so we can cover them in the end, discuss them more later via email if needed, okay? So a little bit about me, as Gustavo mentioned, I've been working with risk analysis tools for many years already. I have a very nice experience, both in terms of different projects, companies, countries, softwares, challenges. So, and I try to bring all of that to our consulting and training work, okay? My expertise is really quantitative risk analysis of large capital projects. Sometimes oil and gas, sometimes mining, sometimes other industries, but my focus is always on the cost and schedule part of risk. I also work a lot with the valuation side, so valuation of projects, looking at future production curves, commodity prices, sales volumes, operational costs, etc. So these are the three pillars of my work: schedule, cost, and valuation, which are all, of course, all connected, as we all know, right? So I'm the founder of ImagineRisks and Analytics, where we offer both all kinds of solutions for both software and training and consulting. So if you need extra help using software or implementing it in your companies or tackling the challenges of your project, feel free to reach out. We can be of help. So let's go into the topic, right? What is Safran Risk and how does it cover the needs we have in mining projects? Safran Risk is a specialized software for risk analysis of schedule and cost. So it's focused mainly on the schedule of the project and the costs associated with implementing the project, with implementing the schedule of the project. It's a tool that runs Monte Carlo simulation to quantify risks, okay? It's extremely user-friendly, as you will see in this presentation. It allows modeling all types of risks, sometimes in a very shallow, simple, straightforward way to get the model up and running, to get people interested in understanding what you're doing, sometimes in a very deep and realistic way if you need it. For example, we're talking about, let's say, weather events. Weather events, you may say there's a 20% chance that there will be some disruption of your construction plan of whatever task you have on your running construction on your site. So you may simply specify it as a risk with a 20% chance of occurrence and an impact of 10, 20 days. Or you may model schedule risk as a more calendar risk or weather risk as a more detailed aspect of the calendar of the project. So the calendar over the days of the year have a higher or lower probability of being problematic or not. So instead of a single 20% probability of running into trouble or delaying a certain task, you do have a calendar behind your schedule that matters for not only this task, but for every task of your schedule. There may be many tasks that are impacted by the calendar, for example. So you may create a very simple, user-friendly, shallow, easier risk model, or a more complicated one, deeper, more complex if needed, depending on what the situation is, on what your needs are, okay? It's the best tool I know for schedule risk analysis with a super intuitive interface. Some parts of the interface, in my opinion, are brilliant. They summarize what the model is all about in a very concise, graphical, clear way. Okay, with all the flexibility you need for your models for quick and easy use and reports. So it saves a lot of time when you're using this software instead of other alternatives. Also, we can use schedules. For schedule risk analysis, you start with someone else's schedule. It's a deterministic schedule, right? The plan that your company has or the PMO has to execute the project. So you start with the schedule from Primavera, P6, or Microsoft Project. And then we bring that plan, that schedule into Safran Risk. We import it into Safran Risk to be able to tackle the risks. Primavera and Microsoft Project, they deal with the planning side of things, not with the risk side, right? So here we will start with the planned schedule and we'll add the risks on top of it. We can also import for long-time users of PRA, Primavera Risk Analysis, Master, PRA, all the names of the old software that many people still use. That was very good on its back on the day, right? We can also import models that have been built in Primavera Risk Analysis. So that helps a lot in navigating or translating your current work into Safran Risk. It's not like you have to restart from zero or translate everything to this new platform. There are very easy ways to make this translation from PRA to Safran Risk. A couple of steps and you're there, okay? But why do we do risk analysis, right? Why we're looking at risk analysis of project? We want to be able to manage risks. We want to be able to prioritize ranked risks based on their impact or based on their importance to help decision makers make better strategic decisions. So where should we focus our resources? Time, people, money, right? In making the project run better. Which risks should we monitor all the time? Which risks are we expecting to happen right now or later? Being able to understand that after the quantification is very important. From the qualitative side of things, sometimes we have a risk mapping or a risk ranking from the qualitative side. The problem is the qualitative is not connected to the schedule itself or not connected to the cost itself. And sometimes things that may seem very impactant, very important on the qualitative risk analysis, they are not as relevant on the quantitative side, either because they run in parallel with other things, or because they may be swallowed by other risks, or because the risk driver underlying that and other risks is a common thing that matters way more than everything else. So on the quantitative side, we have a much better view of how risks are actually going to impact your model. And that's why we need, of course, a realistic schedule to start with, okay? We'll be able to visualize risk in many different ways. Tornado diagrams, cumulative curves, histograms. We'll be able to understand how the critical path changes based on whether risks happen or not, or which risks are part of your critical path and which are not. We'll be able to look at schedule and cost jointly using scatter plots, which is a very interesting way to understand how these two things are connected, okay, in your project. And the focus of Safran Risk is actually complex, large projects, okay? It's widely used in capital-intensive industries, such as oil and gas, construction, infrastructure, mining, like we're doing here, okay? So Safran is the ideal tool for organizations seeking a comprehensive view of risks, combining both accuracy and ease of use. Then we're going to apply here all this methodology and the software to a mining project, okay? So risk analysis of mining projects. Now, this picture is from a BBC coverage of a project in Brazil, a mining project in Brazil, where I'm based, that has been facing very complicated opposition from communities. So a risk probably that they imagine on the qualitative risk analysis, problems with the community, that is actually happening and delaying the project, accruing costs, maybe even turning the project unviable, I don't know, depending on how it goes. So this is a real picture from a real project where risk analysis is very relevant right now. Not the projects I work with. I got something from the news, so we don't have any confidentiality issues, okay? So what's the scope here of our analysis? The construction or execution schedule of a mining project from planning to commissioning to delivery, okay? So from the planning phase, then execution, commissioning, and finally delivery of the project. We have things related to project management, licensing, engineering, procurement, the actual execution, construction of the project, equipment installation, assembly. And in a mining project, you have very large pieces of equipment. You have very risky things going on, imported equipment, a very complex supply chain sometimes, okay? Expensive equipment that are mostly custom made for the project. So it's not, there are many risks that perhaps other construction projects don't face, for example, okay? We'll be considering here this triad of schedule, cost, and risk during our analysis. Of course, focusing on how risk makes schedule and cost change and deviate from what we planned, okay? So what are the risks that we're going to work here on this example project? First, uncertainties, variability, the natural variability of schedule and costs. So the risk, the project is based on some assumptions. When you look at the schedule of the project, it's based on some assumptions of how long each task should take. What are the connections, the links between tasks? What should I do first and then second and third? There are some assumptions within the schedule of the project. Also within the cost model, the CAPEX model of the project. These assumptions, even though you may have some contracts already in place, they still carry a lot of variability. Well, things that are just estimates tend to be more variable or more uncertain than things where you already have a contract. But even when you have a contract, there is still uncertainty regarding volumes, regarding exchange rates, or even regarding the performance of the contract, right? So there is a natural layer of variability on top of everything that you planned for. Even before you mention external events, even before you mention problems. So what you planned for already carries a certain level of risk, which we can tackle within the risk analysis. That's one pillar of the risk analysis. The other one is the internal project risk factors, such as construction risks, supply chain problems, logistics, reworks, quality assurance, accidents, things related to the tasks of your project that will probably happen within the perimeter of the project, right? But which are not part of your plan. You don't plan on, doing reworks. You don't plan on facing accidents, but we can't realistically imagine we're not going to face any of those. So those are risks that may or may not occur, which are part of your project. That's the second pillar of our risk list. And the third is external risk factors. So risks such as weather events or extreme weather events, problems with licensing, political, community, image problems that may affect your schedule or your deliveries or your capacity to execute the project. Inflation, cost escalation, things that are external to your project. But then again, we are not immune to these events, and if they happen, they end up impacting your project. So these are the three pillars where most of the risks that we can imagine, most of the risks that the project faces, will end up being part of one or the other, one of these three pillars, okay? And we have the tools to model them all in Safran Risk. Specifically for a mining project, the typical risks that we face, the ones that are always there. First of all, scheduling cost, of course, uncertainties in the schedule and the cost of things, especially the big pieces of equipment, the expensive things in your project. Supply chain risk, many things come from far away or from abroad. So there is supply chain, both in terms of delays and also extra costs, okay? Sometimes you're approving and starting a project, starting the execution of a project, and you don't even have all the engineering specifications to be able to work with your procurement team and guarantee the supply, right? So there are many challenges that come from even from the way we manage the project. We try to make things faster, but sometimes we add extra risk when doing that. It still pays off, but we can quantify that. We should quantify that. We also have safety construction risks, so things related to the construction itself of the project, right? Big pieces of equipment, many people working on site, usually far from any civilized area or city or anywhere else. So usually off-site, far from other areas, from urban areas. That adds a lot of risk here in the construction side. External risk factors such as weather, macroeconomy, they're always there. But this is valid, I think, for any kind of project, right? Typical risk of any kind of project. Specifically for mining projects, what we see often is environmental permits and licenses are a very big issue. In Brazil, it sometimes takes more than 5 years to issue an environmental license. I could say a larger number than that, and I wouldn't be lying. So it's very complicated. And not only it takes a long time to do it, it gets delayed along the way. So usually what seems to follow a certain process and have a certain time to be deployed might take a way longer time because of delays, extra studies, etc. Usually mining, you're dealing with sensitive environments, and environmental licenses are a big problem. I know that in other countries, it's not very different from this. Mining is a very it's on the spotlight for environmental issues. So environmental licenses are always a big problem, and the risk of delays is always there. Okay, way more than for anything else for any other industry. Also, there's many risks, especially on the qualitative side, related to the company or the project image. So depending on how you deal with local communities, on how your company deals with the environment, how your company deals with maybe indigenous people, you may create a very big image problem. So I have to tackle those. And even though, image and company image or project image doesn't have anything to do with schedule and risk and schedule and cost at first, right? If you don't manage these things well, they may create a risk. The risk may happen, and then it may affect your schedule immediately. It's very common for these kind of things to affect your schedule because image risk ends up, connected with your environmental licenses that get delayed because of some kind of prejudice against the project or some image risk. And so it goes. It's a snowball. So even though company and project image doesn't have an immediate impact on schedule cost, sometimes it's something we have to consider. We don't talk about this kind of stuff in other industries, mostly mining, oil and gas also, but specifically mining, this is very, very sensitive too. And also communities. The footprint of a mining project is very large, right? So communities around the site are heavily affected, often heavily affected, and often they get together, they organize, and they oppose the project. On the other hand, sometimes some companies have a more proactive approach of going into these communities first, implementing some things in the communities, such as schools or technical schools, so that these people can actually work within the project. They can actually help the project, and the project actually helps the community. There are many proactive ways to counter this, to mitigate these risks, but communities is a big risk in mining also. Oil and gas too, but I think mining is more sensitive than oil and gas also in this front. And communities may sometimes, become the risk factor or the risk driver for your schedule delay. So again, these things are not an immediate schedule or cost risk driver, but they might be a risk driver behind your delays. They may present some delays. In this specific problem from the picture here, this is actually happening. So some things we have to consider specifically in mining, okay? And all of those, of course, we can translate those qualitative risks into quantitative risks. And when I say that, I'm talking about what's the probability and what's the impact. Those are the two main vectors of how we quantify risk, the probability that the risk may or may not occur, or the frequency that it occurs, and the impact. When it occurs, what is the impact over your cost, over your schedule, over your resources, for example, okay? So all of those can be modeled within Safran Risk here with no problem, okay? So we see now how we go through this risk analysis model step by step within Safran Risk. So I'm going to open the software, and we're going to take a look here at how our schedule, what our schedule looks like, what's the cost associated with the project, how we can map the risks, understand the risks, and map them to each of these tasks, etc. Okay, we'll see how we do that in the software. Here I have already started by importing the schedule from Microsoft Project or Primavera into Safran Risk. This is the interface of Safran Risk, where we go through all of these tabs of home and then schedule warnings, what are the project risks, how do I map each risk to each individual task of the project. We'll analyze this risk analysis. We'll run the Monte Carlo analysis of this project with all the risks participating in the analysis. And then after that, we'll have some distributions graph to look at. We will have some cost schedule distributions to look at. We'll have the risk drivers that mostly impact our project to analyze here. So for example, if you're looking at the final project handover, what are the most important risk drivers behind the final project handover? If you're looking at some other parts along the way, assembly of the plant, for example, what are the risks that affect this specific item? There are some sensitivity analysis, some other extra analysis we'll take a look at along the way to understand how this project responds to the risks, okay? So it all starts with your schedule, which in the ideal world should be detailed, realistic, not overly detailed because our assumptions can only go so far, right? But a realistic schedule with something around maybe 1,000, 2,000 rows is what we usually work with in a comfortable way. The software itself can work with any schedules of any size. I have something against schedules that are too large or too detailed because our assumptions on how things are connected to each other and their duration, this degrades quite fast as you add more detail to the schedule. So I like working with a schedule, sometimes a macro schedule of 200-300 lines, sometimes a more detailed schedule with 1,000-2,000 lines or 1,000-2,000 items, and that's it. If you go into too much detail, the software works, the risk analysis works, but you run into a problem of good estimates, okay? So apart from that, our project here has a planning phase where I'll do some something related to some tasks related to regularizing the land, some initial contracts, initial permits, environmental studies, these important things that happen in the planning phase. Then I have what we could call the FEL2 phase, right? The conceptual design of the project. So conceptual engineering, infrastructure, environmental permits that usually end up being also required on this phase. Then after that, we have the basic design phase of the project, so the more detailed basic engineering project. The procurement phase after that, where we start, and then I'm breaking this apart. Some people, this is still part of FEL3, right? But then I'm breaking apart the procurement phase here, where I'm bidding for the different parts of the project and equipment and things and fabricating them and delivering them. Then the execution phase, which starts midway the previous phase and ends up with the connection of all equipment to the power supply, installation of the most important pieces of equipment. The process plant, the structure of the process plant is also executed here, assembly of the process plant, and etc. And then finally, commissioning and handover, where we will commission all pieces of equipment, run all the functional tests, integrate tests, and finally, the project handover. So a very brief, a summarized view of the whole project, okay? Not going into too much detail because we want to keep this webinar a little bit simpler, okay? But then looking at these tasks, and here we have the duration that we estimated for each task, the cost that was estimated for each task too, okay? How can we implement or how can we map risks to this project? So first of all, before we go into the risks, let's take a look at the schedule itself is proper for risk analysis. So there's a warning page here where I have some schedule warnings where the software will tell us whether some of these risks, usually this runs by the tens or hundreds on a real schedule, or an initial schedule. The software tells what kind of activities you have in your schedule that may affect your risk analysis in a way that maybe perhaps you haven't thought of. For example, here I have an activity here, an open-ended activity with no successor. Well, that's the project handover, so that's okay. I don't have a problem with that. The final project milestone, it doesn't have any successor. That's fine, okay. I have some other things here that have no predecessor. So the initial project planning, okay, that's fine too. Now these ones in the middle, those are tasks that for whatever reason, they don't have successors on my schedule. This is a problem, right? Even before we talk about risks, we need a schedule that makes sense. And if I have activities here that have no successor, why am I doing them? Why do they matter for my final project handover if they're not even required for the handover, right? For the final milestone. So all activities should actually have some kind of successor or also predecessors, right? So the schedule warning tool here will look for predecessors, successors, lags, tasks out of sequence, things that, you know, the paper accepts, the schedule in Microsoft Project or Primavera will accept. But for the risk analysis, they don't make sense. And keep in mind that when we analyze the project, we're actually gonna create thousands of scenarios for this project, thousands of possible scenarios for the project. And I want to have a schedule that makes sense to be able to run the Monte Carlo analysis, okay? So one thing we should do here, we should make sure that all of these tasks, they are actually, you know, connected to some part of our schedule. So 152, 53, 55, as you can see them here at the bottom. Those are the three tasks that are not, they don't have a successor, and perhaps they should have a successor, right? So before I start, for example, task 155, I want to make sure that all of the other tasks are finished. So I'll add them all as predecessors over here to make sure that the model is realistic. So 54, 53, 52. So those will all be now predecessors to energizing, to turning on the power of the whole set of equipment. So now they have successors and they disappear. It seems that 155 doesn't have a successor too, so I will add it as a predecessor here to the next one. So now I have no more warnings. The two warnings that I have are acceptable. I can move on. This is even before we start dealing with the risks themselves, okay? We need a schedule that makes sense, both in terms of resources, predecessors, lags, etc. Now, the risks themselves. So what kind of risks do we usually face when we look at a project, at a mining project? If you remember the PowerPoint we had earlier, I was breaking, you know, the risks into in three pillars, three distinct sources. One, uncertainties in scheduling cost, the variability of the planning assumptions. So everything we plan for here, the duration of each task, mainly, right? The cost also, but mostly the duration of each task, since we're dealing with a schedule. That's just an estimate. So what I'm gonna do, I'm gonna separate my project into tasks that face a lower level of risk. So I'm calling them low, estimate variability, low uncertainty. So these tasks that belong to this lower class of risk or the higher class of risk. So the ones that belong to the lower class of risk, I will state that they have a variability of about plus minus 10%. So here in the software, I'm saying that this kind of risk is an estimate uncertainty. It will affect the task duration and cost. So the schedule impact and the cost impact are both on. And by doing this, I'm saying that the variability of 10% in duration plus minus 10% in cost. So some tasks will be part of this class of risk, okay? Some of the tasks are more complicated and I perceive them as more risky. Things that can hardly go any faster. So the schedule impact is only minus 5%. And if they delay, they can be delayed by a lot. So here in the software, I'm saying that the uncertainty on the schedule, the duration of these tasks that I will map this risk to, they can go a little bit faster or a lot slower, take a lot longer, okay? And we can do this in the software in a number of ways. First, you can risk and impact both schedule or and cost or either of them. Also, the impact can be a relative impact as a percentage. So maybe a duration with a task of 100, we have -5 plus 50 days. A duration with a task with a duration of, let's say, 20 days, will go, maybe it will run maybe 1 or 2 days faster and 10 days slower, longer, that duration, okay? Or it can be an absolute value. So you specify the number of days that the risk adds to the task. When we're talking about variability, we're usually thinking in terms of relative. So a task that takes, let's say, 20 days and is low risk versus a task that takes 50 days and is low risk. So the variability is relative to the size of the task, right? Usually that's the way we think, and the software allows us to do that. Some other tasks, when we model them, we'll model them as, like the first one here, critical equipment delivery delay, we'll model it as an absolute delay. So if this task here, delivery of processing plants, mechanical systems, if the mechanical systems get delayed, I'm expecting a delay between 30 to 60 days. So whatever 139, how long does that take? Let me just check here real quick. So 139 is here. It's supposed to take 20 days to be performed. If this risk happens, it will add another 30, 40, or 60 days, or anything in between to this. Now, something should take 20 days. Let's suppose if it's produced internally, locally, let's say in a nearby city factory. But if you have to import it for whatever reason, there's a delivery delay. This delay is quite long. That's why I imply here. So it's better to use this as an absolute than a relative. So you see, we can represent the risks the way they actually behave, and we have the tools inside the software to do that. Coming back here to our low and high class of risks. So these risks here, the tasks in our project, they will either face no risk at all. Maybe it's something that I already have a contract for, or some duration that has no uncertainty, or I will represent them, I will flag them as low risk, plus minus 10% in scheduling cost, or high risk, -5 plus 50% in both schedule and cost. So all of the tasks of my project will belong to one or either category. Well, of course, I can still make a risk I can still leave a task without any risk impacting it, of course. But most of the time, tasks and costs are somewhat variable. So we represent them like this. On top of that, we also have another source of risk, which are the internal project risk factors. Things related to supply chain, logistics, construction, risks that may or may not occur, but they are part of your plan, right? Such as critical equipment. You have to purchase critical equipment, right? You have to get your environmental licenses. There are, for example, international suppliers for some of the pieces of equipment you have, and so it goes. So these risks, each of them will be modeled individually. And some of these risks will impact only a single task. Some of them will impact more than one task, okay? Here, there's one genius thing on the interface of the software where we separate the risks. They are mapped here. Each risk will have a probability of occurrence and an impact when it occurs, right? But we separate that from the risk mapping. So which risk impacts which part of your project? So let me just expand this real quick here. So each activity, each task of my project may be impacted by one or more risks. So let me get one here, for example, that's interesting. This one, delivery of processing plant equipment. It is a low risk activity in itself. The delivery itself is not something that complicated or risky, but there is a risk of a critical delay of critical equipment delay applies to this risk, also applies to the one before, power supply. And also there's a risk here, with this one is called equipment logistics, issues in transportation. So both risks, delay in the delivery and delay in transportation, both will affect this specific risk. Even though it's a low variability risk in itself, there are some external factors that may affect it, okay? These internal project risk factors that may affect it, okay? Here on this interface is where I will map what risk affects what task. So for example, if I get the first one here, let me get the first one here, which is initial project planning. Well, there are no risks associated with this one. Preliminary permitting. So it's a high risk activity. The variation typically is very high for this, and I may be impacted by this environmental permit issues problem. Okay, so it's a risk that affected. I could have multiple risks, applying to the same task here. Then I would have multiple sources of impact making this thing be delayed, okay? Or I could have a single risk like permits affecting many different tasks of my project. So on this risk mapping here, which is actually a map, right? It's very easy for you to set up, for you to specify what impacts what, when, how, okay? Actually not how. How is over here. So on the project risks tab, we specify probability and impacts. And on the risk mapping tab, we connect the risks to the tasks, okay? Here on the project risks tab, we still have a mappings, the map information down here to show you what risks are impacted by this, what tasks, are impacted by this specific risk, okay? So these two interfaces, this is where we make the qualitative risk analysis, or we connect the qualitative to the quantitative. So we are now specifying what are the risks. This probably comes straight from the result of your qualitative risk analysis. So the list of risks, probability, and impact comes straight from your quality analysis. And then on the risk mapping, we make this link between risks and tasks. So it's very visual, very easy for you to report this, to see what is going on, what are the risks, what are the activities. You can also run some, if you want, you can also run some filters here. So for example, what are the activities that belong to this risk, or that are affected by this risk, or by this one, or this one. So you can create filters here and even take a look at specific points of view, okay? Also, on this interface, we have something else that is quite nice, which is we have a small, let me get one that's interesting here, additional environmental permits here. So if I look at this task, 122 environmental permits, additional environmental permits, there are two risks that affect it, right? It can be it has a high variability and it's affected by risk number 2. The two risks are mapped down here that affect it. I can take a quick look at what the impact on the schedule will be with these two risks together. So something that should take deterministically 30 days, as we can see on this calculated distribution here, 30 days is the 30 days must be here the black line, right? If these risks happen, well, there's a small variability plus minus something percent, small to the left and high to the right, plus a delay that may be up to 300% the duration. So instead of 30 days, this specific delay may actually make this risk take up to 120, so an extra 90 days. And then you see what you will get from your as a final distribution on your simulation is the distribution like this for this specific task duration. So environmental permits should take 30 days, but most likely will take a lot more than that. In average, 45 days, 46 days. But as you can see, there's a very long right tail here, which is typical in projects. Some tasks are extremely risky. Why? Because they have a high variation on their own, plus there are some external factors that may hit it. I have some other risks, some other activities here that are impacted by 2 or more risks. So have something that should, on its own here, mechanical systems, should face low variation, so plus minus 10% perhaps. Deterministic is 20 days, okay, minimum 18. But there are some risks that may occur and they may add up to more than 100 days to this. So I have here a very long tail, unlikely, but very long tail that may occur. These two risks here are critical equipment delivery failure and transportation issues. I imagine those two have a low probability. Yeah, it's written here, 15 and 30. That's why I have a long tail with a small probability of occurrence. Okay. So on the risk and on the mapping tab, we create the risk model. Okay. After we specify all risks with their probability, their impact, and map them, we're ready to go and run the Monte Carlo simulation. Just a quick last step here. I showed a little bit about risks that affect your schedule, your cost with a probability. But there are some special risks that you may be interested in, slightly different ways you may be interested in modeling, such as the existence or not of a given task, probabilistic branching. So when the connections are probabilistic, the links between tasks may be probabilistic. For example, if you're dealing with new technology, with prototypes, or if you're dealing with different kinds of suppliers, or if you're modeling a bidding process for your project, and there's a probability that no single bidder will show up, that no supplier will qualify for the bidding process. So then you have a branching, choose something else in your project. So that may be achieved with probabilistic branching. And one that is very popular here, the calendar risk. So instead of having a probability of something happening or not, we may associate this probability with the calendar. Okay. When you're dealing, for example, oil and gas, offshore drilling, calendar is very relevant. There are some parts of the year when the weather is more often bad, and more often you have to disconnect your equipment and wait on better wave conditions. And some parts of the year where it's easier to work. It's all probabilistic. Any day may face a big storm, but it's more likely that it happens in summer than winter, or vice versa, depending on the region. Okay. Also, weight on ice is another thing that we could North Sea, Canada, you have weight on ice conditions sometimes for a project, both onshore and offshore, so that might be included here. Non-productive time could be modeled as a calendar thing because it depends on the time of the year. So depending on what task you're performing, the calendar may impact it different parts of the project. And then what happens is that a delay at the beginning of the project may actually translate into a calendar risk becoming more relevant because you planned certain tasks for when the calendar risk is lower. But if you face a delay in the beginning of the project, maybe this task will be, shifted into that time window, into that calendar window where there is more risk. So it's all connected, so it's relevant that we can map to this level of detail. If you want, of course, you can still map something related to environment just as a simple yes, no probability of happening, okay? With that done, we could still talk about correlation and go deeper into what happens when one risk triggers the other, what happens when risks happen simultaneously, what happens when risks have correlation, and we have a whole structure for that within Safran Risk. Okay, I'm not showing the correlation matrix here, but you can specify that risks happen individually, simultaneously. There are some other options for that if needed. I'm not going to go into that right now because we're going to analyze the results. So here we have the place where the math happens, and it's very quick. We ran the Monte Carlo simulation. So I simulated 10,000 different scenarios for our project, okay? And what happens is that you get a distribution for the results of the project, and you can see how long the project might take, not only what you plan, but also how long it might take, how costly it can be, how much more expensive it can be. We can start talking about contingencies and all that. Just before we move into the results, here in the Analyze tab, we can do a few things, which is, first of all, run the model with all risks or just with some risk we specify. So maybe we want to test what happens if you, for example, mitigate that, or after we pass by this phase of the project, or you have some way to mitigate these permits risk. If you mitigate it, what happens with your project? It's very easy to run the project with or without a given risk and check what the results are, check if they change significantly. That way you can answer questions real quick of whether it makes sense to pursue this or not, for example. Another thing we can do, we can specify that we run in the pre or the post mitigation of the risks. Each individual risk in your project may have a pre-mitigated position or pre-mitigated effect and a post-mitigated effect. That can also be modeled within Safran. So the post-mitigated risk may have a different probability, a different impact. It may actually have a cost. The mitigation strategy may have a cost, both in terms of dollars or time to be implemented. So all of that can be designed within your risk interface, okay? So not only look at the project as it is, but we can look at the project from the mitigated point of view, and if it actually matters, if it actually improves by how much we expect, okay? Given that, let's take a look at the project itself. So here I have all the tasks of the project on the left side, and here I see a distribution of the finish date of the whole project. So the OpenMine project, the deterministic date would be 5 of October 2027. As you can see here, it's a very low probability. There's actually 0% probability that you'll finish within that deadline. Most likely we'll finish around or up to January 2028. P90 is already March 2028, and P99 is even May. So there's a maybe 5 or 6 month delay that is quite possible, okay? At least a 2.5 month delay. The deterministic value is quite unrealistic. That's typical for projects where we have a plan, but the plan does not account for the risks that may occur. That's very typical. So here we can start talking about contingencies. Here we can start talking about managing expectations, managing stakeholders in a better way. So instead of promising that you will deliver this at this very unlikely date, let's promise we'll deliver it by March, so that we have here a decent likelihood of P90, 90% likelihood of achieving that date, okay? If you want to play with the numbers, you can actually set different targets here and check what the dates are. For example, let's see what March, let's say 1st of March or the last day of February of 2028. So let's go to February. The last day of February is here. So we have this target here with an 85% probability of occurring. So that would be a very comfortable deadline, one that we have 85% probability of meeting, a realistic deadline, okay? Same thing for the cost of the project. The total cost of the project, we estimated in $52 million, let's say. Very low probability this will be enough. So it's better we already add some about $4.3 million in contingency and specify a budget of 56 million, because we will end up spending more than 52, almost certainly. 92% chances we'll spend more than the deterministic value. That's a very important piece of information, okay? Some companies aim for the P50, so P50 for your budgets. Well, it's not exactly bad, but there's still 50% chances you will spend more than this. So how difficult is it for you to react, or for the project manager to react if there are extra costs? Is it a joint venture? Is it an internal project? The choice of the percentile here depends on a number of things, including how fast you can react to problems, okay? If it's an internal project, if it's a small project for the size of your company, yeah, you don't need a lot of contingency. Now, if it's a complicated project with image risk, with external stakeholders, joint venture, etc., you would want to specify everything with a good degree of contingency to make sure that the project will not be paralyzed or even drop dead along the way, okay? So here on this histograms and the cumulative curve, you find a number of statistical pieces of information that are important and relevant to report. There's also a report you can get here if you want an analyze tab, a report where you get a full detailed report of every chart that the software created, of every single analysis made. You have all these charts also available for each individual task of your project if you want, okay, for the cost, for the finish date of the project, for the duration of each individual tasks. Okay, so some tasks may have a very long duration because of risks that may occur. For example, this one, instead of something around 20 days, may actually take 60, 80, almost 100 days or more, okay? So with these charts, you can easily see what results or what conditions we will face along the way with the project. Given that, we can take the next step, which is understanding the whys. So why is my project so risky? What are the main risk drivers, for example, when you look at the final project handover? So it seems that risk number 2 affecting permits on task 115 is very relevant. Risk number 1, critical equipment, affecting task 138 is very relevant. So here we have a view of how the individual risks may impact individual tasks and how that correlates with your final handover date, okay? Also, the activities driving that date, you can look at that both in terms of finish date, cost, criticality, or how often given some tasks are part of the critical path of this one, for example. So there's a lot of information you can extract here from what are the most critical risks for your project. After that, one question that often arises is, what if we could mitigate some of these risks? And that's where sensitivity analysis comes in. Actually, the statistic sensitivity analysis is often more desirable as one. Let me just run here. Sensitivity analysis is often more desirable as a reporting tool. Okay, here what we have is what is the cumulative curve of your project, the finish date of the whole project. Okay, with all risks turned on. All risks may or may not happen within this project. What if we could, for example, remove our risk number 2, permits? What if we could mitigate that and eliminate that risk completely? Well, that would make your cumulative curve move to the left, or your dates shift to the left, right? And that actually makes your P90 here drop by 26 days. Oh, I was interested in the P50. Well, you can have that for the P50 or for the different statistics if you want. Let's focus on the P90 here. So your P90, which right now is around mid-March, it becomes mid-February. So you drop 26 days, almost 1 month, you improve on your P90. What if you could mitigate, which is not very realistic, but what if you could mitigate the high variability risks, make them vanish? So there's no uncertainty on these durations. Well, the impact would be even greater, but this is probably not a realistic target. You could do that for maybe one task, but not for all of them, right? What if you could mitigate, for example, the weather risks that we have? Well, the weather risk has a very low impact, 4 days. So it's not as relevant, for example, as the permits. So the sensitivity analysis, it turns off risks one by one and compares that to your unmitigated position or one mitigated scenario. So you can have an idea of how impactful each risk actually is on the target that you have, your P90 or whatever P you want, on the finish date, start date, duration, cost of your project, or of specific tasks of your project, okay? So this is a very intuitive way of presenting risk. This list specifically shows you the benefit of mitigating each of these tasks. If we look, for example, at costs, maybe for costs it's even more appealing. For the costs, we have a measure of how much each mitigation will bring you in financial benefits, right? So this is interesting. If you mitigate, for example, risk number 9, safety, you may save $650,000 because it affects the cost of a number of relevant tasks down there. Permits don't have an impact on your cost, though. They create a delay, but they don't have an immediate impact on your cost. Of course, this depends on the structure of your schedule, right? But here we can have a clear idea of how your different approaches or possibilities may affect your results. And then, of course, we can pursue the mitigations that make sense and that are technically available. This is a place where the qualitative and the quantitative often diverge. The quantitative is way more realistic because we are combining all the risks together here, okay? We also have some other charts we could be looking at, for example, the scatter plot of the project. Let me put here the whole project here. Let me get the scatter plot of a given phase. No. Here, for example, the scatter plot of the procurement phase, the dates where we finish the finish date of the procurement phase versus the cost of this procurement phase. So I can see there's a relationship when costs, when the finish date is higher, costs tend to be higher. There are some areas here that might be interesting to look at. The joint confidence interval, I'm not going to go into much detail here on what it means, but it's a way of combining the likelihoods of both costs and finish dates together, so you know how likely is it that you're going to finish both on under your cost or both in cost and in budget, and not over cost or over budget. Okay, so it's a way we can start combining cost and schedule and have a comprehensive analysis of both. Because there are many different ways you can finish both on cost and on budget, or under your scheduled date, your budgeted values, right? And there are many different ways you can maybe hit one target and miss the other, or miss both targets. So the scatter plot can help us visualize that. We also have probabilistic cash flows that we could look at how the money is spent over the lifetime of a project, or the critical path of the whole project or parts of your project. So if you're interested in the critical path, for example, of certain segments of your project, you could be looking at that. Or if you're interested in looking at the whole project, we also have the critical path for the whole project. So, and the critical path, it may actually change depending on what risks happen or not. So some risks are always part of your critical path. Some risks are rarely part of your critical path. And that's a very important piece of information. So if you look at the final project handover, well, there's one path that happens most of the time, and two other paths that may occur depending on how risks manifest themselves. So it seems that we have a very safe bet on the critical path. Now, for some projects, we have a critical path that happens 60% of the time, and another one 40% of the time. That's almost like half and half. So you actually have two critical paths, or two sets of tasks or risks to pay attention to, okay? So all of these are results that we get naturally from typical risk analysis. And here with Safran, we can easily map them, report them, and play around with them. So if someone comes with an idea of mitigating on risk and it's going to cost X million, well, let's see if, turning off this risk and running the analysis again, if it makes sense. Or maybe by doing this, you're turning off 2 or 3 risks. Or maybe it has a cost and it doesn't fix the risk completely. So it's a post-mitigated situation scenario, which you can specify, run the analysis again, and then make these comparisons in an easy, straightforward way. Okay. I think we're still within time, but we should have time for questions, which I kind of ate along the way.
I have one Rafa that that was sent at the beginning of the presentation, but I didn't want to interrupt you. Was does the version of P6 that you use, maybe I'm not sure if you used P6 to build the schedule, had an impact in the schedule that you use, or I'm not sure if you used it or not.
Well, we should be using the latest versions of P6, 22 something up. I think it's on version 22, right? I use P6 sometimes to build the schedule. Many clients use P6 to build their deterministic schedule, so it's a tool I use quite often. I also sometimes use Microsoft Project, but the version itself is not a problem. Unless you're using a very old version, then, well, problems might arise, right? You should be using one of the latest versions of P6, like from the last 1 or 2 years. I think it will be okay. But that's a kind of question that the support from Safran might be able to answer very well. And they have a very good support team, a very good support portal where you can send questions, and they are very responsive. So if you have an issue with that, I would recommend you contact support directly to understand exactly if your version is supported or not. I'm not sure when or what is the requirement within the software for this. Okay, I use the latest versions of P6, so I don't worry about that usually.
Thank you. And there's another one, and this was also related with the number of tasks. This is something that you mentioned. It says, what's the proper level of detail for a schedule to work? Most project
Very
plans
good.
have detailed schedules, and based on the logic, they may mislead us about critical or driving activities. So what's the best practice? So
Very good question. Excellent question, actually. In my opinion, the answer is at some point, this extra level of detail degrades your capacity to estimate things properly. That's the level where you should stop. Of course, uh, I sometimes see schedules in Microsoft Excel, right? Just a table with some numbers and expected deadlines. That's not a real schedule. That's more of a macro or milestone schedule, right? If you go further down the road into the project execution, you will at some point have a fell tree level schedule. Usually that's where we run the best the best moment to run your risk analysis, okay? And that schedule usually detailed to a level where you can still find historical data or where people's opinions still matter for the durations. I'm not even talking about the risk estimates. I'm talking about the deterministic ones. At some point, your schedule, the deterministic durations or the deterministic assumptions you're putting in your schedule, at some point, you don't have the extra detail you add actually makes it harder to estimate. It's like if you're going to, you know how long it takes to make a trip from home to work, but you really don't know how long it takes to cross each street you take along the way, right? So have a distant estimate yourself of how long it takes to go from your home to work, even maybe perhaps an estimate of variability for this total. But if you add more detail to it, or by street, or by flashlight, or by turn, you actually miss the capacity of making distant estimates. What we do usually break apart. Oh, it's 10 minutes. I go 10 blocks, so it's 1 minute per block. That's what we usually do, right? So adding more detail is not adding more clarity. It's actually going the opposite way. At this point, we should stop, or before this point, actually, we should stop the granularity of the work. Of course, the deterministic one needs to reach a level where we have sometimes even service orders associated with the tasks, or people or names or companies that are responsible for the tasks. Of course, for the planning side, you may go deeper down the detail level, but for the risk analysis, we should stop as long as our estimates are still viable, realistic. Okay, that's my personal opinion, and I think it works. We can still work with schedules of thousands of rows at this level, but not maybe 10 or 20 or 30,000 rows. That doesn't make much sense to me from the risk perspective. Okay.
excellent, thank you. And I think that we have a last one, Rafa. Sorry to steal a
Sure.
couple of more minutes. And it says, how can we run a report in Safran post QRA? So I'm not sure what this was from Atif, but I'm not sure. I think I pointed him to, I think that what you're going to do, but maybe you have another idea. Go ahead.
No, there's a number of ways you can export data, for example, raw data, percentiles, graphs from all the interfaces that we have here, okay? But on the Analyze tab, you have a report button where you actually get a report here of, you can customize what you want on the report, but you get a report of all the detailed work that you've done in the project. For example, I want a report with the, let's say, finish date, and let's put here the finish date and duration. I'll turn off the other things so that report comes quickly. Schedule sensitivity of the finish date, and maybe cost graphs, and maybe cost sensitivity, whatever you want on your report, all of these things or some of them. And then when you generate this report, let me just throw it on a proper place. We can open it later. Just generate it here real quick. Okay, so when it generates the report, it's throwing a lot of data on the folder I specified. And then I have my report here. It creates both some Excel, some images, and a doc file with all the report that you ask for. Okay, so the risks that we have, pre or post mitigation, options of the analysis, results of review, and then of course some charts along the way. I asked for a small report, just a few things, so we could get it real quick. But the report can have maybe dozens of pages if you ask for all the data and all the information. And that information is also dumped on the folder that you select as pictures, and so it's easy to find, if you want to throw this on a PowerPoint or elsewhere, all the pictures, all the results from your analysis in a single place. That's very helpful. It's very easy to create reports like this, comprehensive with everything, or if you want, just with the specific things you requested. Okay. I hope I answered that one.
Excellent. Yeah, I think this is, and Native was very, very thankful for that. So I think that those are the questions that we have that remain unanswered. So thanks so much, Rafael, for the time.
Thanks
and
a lot
for sharing with us all this knowledge. A lot of people, more than half of the people, stayed a little bit more. So thanks everyone for staying, and we will be publishing this during this week. So you can see Rafael. Rafael's contacts are there, and also we already published his data center video from last week, from 2 weeks ago. So thanks everyone, and thanks everyone for coming, and we will be publishing more webinars in the coming weeks. Thank you, everyone.
Thanks a lot, Gustavo. Thanks a lot, everyone.
Thanks,
Bye-bye.
everyone.
Thank you, Rafa. Take care. Bye-bye.
Take care.